In this section, we're going to look at how we can get activity and screen lifecycle callbacks into our injectable objects. This will allow you to keep things isolated from your activity and controller classes while still being able to clean them up and reinitialize them at the appropriate time. The activity lifecycle task will be an abstract class that objects can extend if they wish to get activity lifecycle callbacks. We'll simply inject the set of activity lifecycle tasks that Dagger compiles for us and call through the relevant methods on each task in the base activity. The screen lifecycle task will have callbacks for when the screen is shown to the user, when it goes in the backstack or is popped, and when it is destroyed. As you see in the animation, when a new screen is pushed, the screen lifecycle task for the previous screen receives the onExit scope callback. The incoming screen's tasks receive an onEnter scope callback. When a screen is popped, its tasks onExit scope gets called, followed by onDestroy. And now the screen that was in the backstack calls onEnter scope for all of its tasks, since it's now the visible screen. Some examples of what you might do in these callbacks are updating the toolbar in onEnter scope, stop listening for click events in onExit scope, and disposing of any disposables from the activity level in onDestroy. We will take advantage of these new tasks more in future sections, but the things we'll cover in this section are converting our screen navigator implementations to be self-reliant as activity lifecycle tasks, and we will also create objects to handle the toolbar setup for each of our screens, and then we'll look a little bit more into Dagger multi-bindings and how we use them.